Good day, everyone. All right, so in this video, I want to talk about question 1A from the 2022-2023 paper for semester 2. Okay, so let us just go through the question. Two charges are placed at the corner of the right angle triangle as shown in the figure 1. Look at figure 1. Calculate the magnitude and direction of the electrostatic force acting on charge 8 microcoulomb. So I want to focus on the 8 microcoulomb. Now, if we look at the diagram, the good thing is that there are only two interacting charges and one of them is positive, the other one is negative. So what that means is that the forces between them will be attractive. Okay, now I want to choose my x and y axis. Let's just choose like that. And then the angle, the direction of the electrostatic force is simply going to be theta, which I have labeled here. Now notice that if this line, the 7 centimeter line, is parallel to the x-axis, then this theta is the same angle. These two are the same angles. So then I can immediately say that theta is actually equal to the inverse tangent of 10 over 7. So opposite over adjacent. Okay, so then I'm left with approximately 55 degrees. So 55 degrees below chosen x-axis. So that's nice. Now I know the direction of the electrostatic force. Now, what I need to do is figure out the magnitude, and the magnitude of electrostatic force is given by Coulomb's law. Okay, which simply says going to be K Q1 Q2 over R square. Now R is just the distance between them. It's going to be this one, and that is going to be the square root of 0.1 squared plus 0.07 squared square rooted. Now notice that even though I have 10 centimeters, I have written here 0.1, and the reason because this has to be in SI unit, which is in meters. So 10 centimeters is 0.1 meter. Okay, here if I just square both sides, I'm left with 0.1 square plus 0.07 square. Now I can substitute the values for K, Q1 and Q2. I'll have 9 times 10 power of 9. I'll have 8 times 10 power of negative 6. Then I'll have negative 5 times 10 power of negative 6. Okay, and then the bottom I'll have 0.1 square plus 0.07 square. Now take a minute to key that into your calculator, and let's see what you get. Okay, so if what you get was 24.15, the negative of 24.15 Newton, then you are correct. Okay, you are correct. After this, what we want to do, let me clear everything up. After this, what we want to do is we want to look at question 2. Okay. Okay, and we're back. Now we want to look at the second part of question 1A. All right, so we've done the first part. Now we want to look at the second part. Okay, calculate the magnitude and direction of the electric field at point P. Okay, so we can imagine, so in order to us to determine the electric field, we can imagine putting a very small positive charge at point P. Now positive and positive will repel, so the forces will be downwards. Okay, this is how we imagine it. And then positive and negative will attract, will be attractive, right? So for the positive charge at point P, it will experience two sort of forces, or it will experience electric field from two sources. So when we see triangles like this, or combinations of vectors like this, we will have to use resolving. We will have to resolve. We will have to use trigonometry and Pythagoras' theorem. Okay, so where do we get our x and y? So let's just assume that going up is positive y and going to the right is x. In the x direction, we have the electric field. We have the electric field from KQ -5 over R -5. So we have K is just 9 times 10 power of 9. That is nice. And then Q is just -5 times 10 power of -6. And the distance from P to -5 microcoulomb charge is 7 centimeters. So that is 0.07 squared. So then, okay, you can key that into your calculator to find out that that is simply 9.18 times 10 power of 6 Newton per Coulomb. 9.18 times 10 power of 6 Newton per Coulomb. That is the electric field in the x-axis. In the y-axis, in the y-axis, I will have again K and then Q of the positive 8 microcoulomb charge and the distance from it squared. So then I can substitute the values, 9 times 10 power of 9 and then 8 times 10 power of -6, and then I will have a distance between them of 10 centimeters. So that is 0.1 squared. Okay, again, take a minute, pause the video to key that into your calculator and see what you get. What you'll get is actually 7.2 times 10 power of 6 Newton per Coulomb. Okay, now we have found EY and we have found EX. We have to combine them. So here we have EX and here we have EY. In order for us to find the resultant electric field, we will have to use Pythagoras' theorem. Okay, so Pythagoras' theorem says that my E square is simply my EX square plus my EY squared. I can square root both sides to get E equals to EX squared plus EY squared square rooted. Okay, so time to substitute those values. I'll have 9.18 times 10 power of 6 squared plus 7.2 times 10 power of 6 squared and then square root that. Okay? Okay. So now, if you key that into the calculator, what you'll find is that the electric field, the resultant electric field at point P, right, will be approximately 11.67 times 10 power of 6 Newton per Coulomb. Now you have to find the direction as well. So we want to know what is the angle, right, of theta. And that angle of theta is just the tangent theta equals to opposite, which is EY over EX. So the good thing is that the 10 power of 6 just cancels out and I'm left with 7.2 over 9.18. Okay, and that tells me that my theta is going to be equal to 38.11 degrees. And that is my direction, is the direction of the electric field at point P, and the magnitude is 11.67 times 10 power of 6. Okay, that is all for me in this video. Thank you very much.